Pencils down, colored pens up. I will remind you for the rest of this week, but after that, no more. You should just do it automatically. Remember, black pen is not a replacement for colored pen. It must be a bright, easy to read color. First, let's see how we did on today's warm-up. Number 1, what did we get as your solution? We got 1, 2, 3 confident people whose hands went right up. 4 confident people. We'll start with Mark, Kianis, Angela, and then Emily.
X equals 15.
Okay?
X equals 2.
Okay?
X equals
Okay?
-16.
So we got 3 different answers. 2 people agree. Shannon, Natalie, and then Tatiana.
X equals -16.
Seems to be more support for that.
X equals -16.
Even more support.
X equals -16.
Seems to be more support for -16. Number 2, the ugly beast of a question. What did we get for that? Crickets. We got crickets. So let's go to the equity. We got student number 10, student number 20, and student number 15. Where's 10? 10, where's 20? And number 15. Of course, 3 people I already called up. Tatiana, go ahead. Okay? And finish. Give me a thumbs up if you have an answer for number 2. Okay, that's fair. 1, 2 people. Okay. The correct answer is -2/9. So let's talk about number 1 and number 2. Give me a thumbs up if you got number 1 correct. Good. Put your thumbs down. Tell me your name again. Daniela. We're going to go from Daniela, and then are you Isabella? Okay, Daniela, what was the first thing you did for number 1?
I would -3 times
Okay. Could someone else tell us what that's called? Isabella's going to do the next step, but what is what she did called? There's a name, and you have to know it off the top of your head. Instant. 2 people know the name? Tristan. Beautifully said. That is distributive property, and so she went here, and is that all you did? What? Very good. The arrows are important. If you haven't already gotten the habit of drawing arrows, get in the habit starting today, moving forward. You must draw the arrows. But there's something else that you have to be aware of. Because she clearly knows what to do, but now she could also make a simple mistake. That's a -3. So you have to be careful with that, because that's a -3 being distributed to a +2x, and a -3 times a -9. So you have to get used to and train your brain to see these negative signs and these subtraction signs for what they really are. They go with the number immediately after. So what was the result of what you did?
-6x plus 27.
Very good. The first arrow will get you -6x. The second arrow will get you +27. Great job. Now, we didn't use the 8x, so we'll put that in. We didn't use the equals, and we didn't use the -5. Put those in. Isabella,
Combine like terms.
you said that beautifully. What are the like terms in this case?
8x and 6x. -6x.
Oh, I love the way you caught your mistake, too. 8x, and that is a -6x. And when we add those together, Isabella, what do we get?
2x.
You get 2x. Let's see where my super brilliant students are for today. How many steps are left? How many steps are left? So I got 6 hands up, but I should see every hand up. Travius, how many steps? Jacob, do you agree? Speak.
3.
3. So you don't agree because he said something different. Mark?
4.
4. Shannon?
2.
2. Natalie? Angela? Aaron? How do you know there's 2, Aaron? Because it's a two-step equation now. Now it's ax plus b equals c. So very good, Von Travius. You started us off. You should be able to recognize this instantly as, oh yeah, it's a two-step equation. I'm a master of that, and now I know exactly what to do. So honestly, I don't need to do anything else. We could stop right there, because you should know what to do next. But for today, I will go through the rest. Subtract 27, and uh-oh, we entered our next danger zone. 2x and nothing is 2x. That cancels out, equals, negative 5 minus 27. What do we get as a result of that? Ethan? Negative 32. I cannot tell you how many students mess this up. And that's tragic. To do all this hard algebra work and negative 5 minus 27 and get the wrong number. A lot of students get negative 22 here and get a result of 11, or negative 11. But now you can easily see, divide by 2, x equals negative 16. Comments, questions, concerns on number 1? Nothing at all? So as far as I could tell, I had 1 or 2 people who had an answer at all for number 2, and whether they got it right, I don't know. But does number 2 really look that different than number 1? Let's compare them. Can someone point out one difference between the two? One difference that you see. One difference. Go ahead, Jacob.
The x and the distributive property doesn't have an end.
Okay. So inside, I love the way you said that. Inside the distributive property, there's a 2 here. That doesn't have that. Great. Another difference. Natalie. There are fractions. Instead of an 8, there's a 1/2. And instead of a negative 3, there's a positive 2/5. What other differences do you see? Mark? If they stole yours, I apologize. Did they steal yours? Okay, anyone see anything else different? So let's recap for a second. The distributive property is easier, and there's only one other difference, that there's fractions instead of whole numbers. Is that accurate? So, unfortunately, you got tripped up, not because you can't do algebra, you got tripped up because you don't know how to deal with a fraction, and that's all. So I'm going to quickly show you what you should have gotten to. Distribute 1/2 x plus, that's 2/5 x. What about 2/5 times negative 2? What are we supposed to get for that? See, everybody should have no problem with that whatsoever. It should be instant. 2/5 times negative 2. So if you're still not developing that confidence, you got to get there. Ethan. Negative. Yeah, what? I want to know what it is. You helped us out. It's a negative. Thank you. Go ahead, Angela. Yeah, negative 4/5. What's the problem, people? We're multiplying. 2/5 times 2. Multiply the tops, multiply the bottoms. It's 4/5. You're making it too hard. Multiplying fractions we've been working on since last week. Negative 4/5 equals negative 1. I'm not saying it's super easy, but some of you are making it much harder than it is. You guys are way too bright to be getting stuck with a simple fraction. So now, if you follow the pattern, look at what happened. It's the exact same setup as right here, except instead of whole numbers, there's fractions. Everything else is exactly the same. And Isabella talked us through combining like terms to get this. So guess what? Combine like terms. The only difference is Isabella can quickly go, oh, 8 and negative 6 is 2, and Isabella cannot go 1/2 and 2/5 is, and she doesn't know. But she doesn't realize that it's super easy. What's the common denominator that we need to make this work? Deja? 10. So you're so afraid or you get so stuck, but it's really no big deal. If we make this something out of 10x, and we make this something out of 10x, well, no big deal. This has to be equal to 1/2, so that's 5/10, and this has to be equal to 2/5, so that's 4/10. So now is combining like terms really that hard? It's the same thing. Here, you add this and this. Here, you're going to add that and that. And so we end up with 9/10 x. Still didn't use the minus 4/5 equals -1. Let's see which of my super smart students is paying attention now. How many steps do we have left? Bless you. How many steps? Sean? Yeah, it's a 2-step equation. It's not a very friendly one, but it's a 2-step equation. 2 steps left. I'm not going to do them, but 2 steps. Any comments, questions, or concerns? Christian?
I got -0.2 with a line on top.
And the original answer was what? -2/9? That's the same thing, right? Okay, I'll take it. Any other comments, questions? All right. Today we take a pretty big leap. We introduce the idea of an equation with a variable that exists on both sides of the equal sign, which increases the complexity of the equation. We're also going to finally explore some real-world examples of how these things are used. So let's jump right in. The new goal that we have, building from last time, is that now we have to collect all the variables on one side. We cannot solve an equation unless they're all on one side. The goal last time I had put up said you had to isolate the variable on one side. Well, if they're on opposite sides, how can we isolate it? They all have to be together. And here's a little hint that you don't have to do, but I still do from when I was a kid. It is by far the best hint for things like this, is for equations like this. You always transform the side with the smaller coefficient. Transform the side with the smaller coefficient. That is going to make it work a little bit easier. It will work either way, but it will work a little bit easier doing it this way. So, what do I mean by the smaller coefficient? Let's look at the equation I have set up on the left. Right over here. There's a variable on the left, and there's a variable on the right. One of them is smaller than the other, and that's where we want to start. Which one is the smaller coefficient? Should have everybody's hand up because it's just a matter of looking at 2 numbers and seeing which one is smaller. Deja? 2. What do you think, Melinda?
2x.
Okay, so we got a whole bunch of hands went up really fast. Tristan? So now we disagree on this. Okay, Von Travis? I think it's the 2. Shannon? Oh, so now we're back to -4. Natalie? Okay, now we're kind of split. Kianis? You think that's the smaller, Sean?
-4.
You think it's the -4? Yeah, -4x is smaller, and I tricked you a little bit because you're looking at the number itself without the sign. This is positive 2x, that's -4x. Negative is smaller than a positive. So -4x is smaller. And so that's going to be our starting point. I'll teach you what to do in a moment. What about the equation on the right? There's a variable on the left, and there's a variable on the right. Which one has the smaller coefficient? The smaller. Danielle? You think it's the 18? Ethan? Yeah, it's going to be the 18z has the smaller coefficient. That's going to be our starting point. Does anyone have any questions or comments so far? Okay, now, within what we're going to learn today is some special cases. And this is where there's a big difference between last year and this year. Because now we have a lot of special cases and unusual things that happen that we have to be aware of. And one of them is called an identity. And an identity is when an equation is true for every number. An equation is true for any number. So what do I mean? An equation is true for all values of the variable. That's a fancy way of saying every number. All values of the variable. You can call it an identity. You can also say all real numbers, which is what you will see the most in my class. Or you may see many solutions. So identity, all real numbers, many solutions are synonymous. Synonymous means they all mean the same thing. So, for example, z equals z. That is an equation. There's a variable on the left and a variable on the right. I would love to solve the equation, however, when you solve it, you find out that no matter what number you put in, it will always work. Because if we put a 1 here, that means we put a 1 here, and that's 1 equals 1. That's true. We could put a negative number. Negative 18 and a negative 18. Negative 18 equals negative 18. That's true. No matter what number we put in, it will always be true. Negative 14 equals negative 14 is also an identity because it's also it's always true. And now you can get even more complex, but here the idea is to just recognize that when you have the exact same expression on both sides of the equation, it's going to be an identity. Because no matter what number you put in, it will always work. If I put a 2 right here, 2 plus 1 is 3, but then that means I have to put a 2 here. 2 plus 1 is 3. 3 equals 3. No matter what number I put in, it will always work. Negative numbers, fractions, decimals, it doesn't matter. No matter what I put in, it will always come out true. And again, that is called an identity or all real numbers. So we're going to see how this falls into the concept of the day. Any comments or questions? Okay, now, I'm going to use a technique with this class that I don't use with every class. It's called most difficult first. And what that means is, you know how last time I ended with a really difficult question at the end? We're going to do that one first. And then we're going to get a little bit easier as we go through. So the first question is going to end up being the hardest. Don't worry, you'll see why. So let's jump in. So, to make sure we're all looking at the same thing, 1/2 times the quantity 12 minus 6x, close parentheses, plus 12 plus 2x equals negative 5 times the quantity x plus 2. That is a beast of a question. But my students can look at a beast of a question and pause and know exactly how to attack it. Because you have this mantra in your head. Simplify, then solve. And the things that we have to simplify are distributive property and like terms. When we take care of that, then we can solve. And remember that we actually have to do distributive property first and like terms second. So if you can just handle doing this in order, then you're totally fine. So let's scan the question with our eyes. Literally scan across. Do we see any distributive property? If you do, raise your hand and let me know where it is. Where do you see distributive property, if any? Isabella?
-5 x plus 2.
Good. So we have an example of distributive property right there. Is that it? Okay, that's it. So we'll do that. Distributive property. And of course, you already know that we distribute. Don't worry about the rest. Just going to deal with this. In fact, I'll make it easier for us. Let's just get rid of this for a minute. That's easy. That's not very intimidating, is it? So, -5 times x, -5 times 2. What do we get as a result? Jacob?
-5x plus 10.
-5x, but you got fired. I'm sorry to say. Go ahead, Melinda.
-5x minus 10.
That's right. -5x minus 10. -5 times 2 is a -10. Very good. So we did distributive property. So now let's bring back the rest. So now we have to do like terms, right? Someone help us out. What's next? Don't be scared. It's a safe place to make mistakes, so just get involved. All right, number 9. Where are you?
Yeah. 5x.
That would be awesome, but to combine like terms, they all have to be on the same side of the equation. So we're not quite ready to do that. Okay? That's a good idea, but we're not ready. Okay? And thank you for being brave. Where's number 24? Nobody. Number 1.
You have to do distributive property
Again? Well, we just did it. I want to do it again. I don't like that.
again. It's on the other side.
Oh yeah, distributed property right there. Look at that. There's actually 2 of them. Yeah, she's right. So we have to distribute again. Distribute. And I know you're terrified of the 1/2, but 1/2 is ridiculously easy. 1/2 times 12 means 1/2 of 12. What's 1/2 of 12, Sean? Yeah, was that hard? Okay. That's 6. Now, this is 1/2 times -6x, but when we multiply it, we're multiplying the numbers together. So now I'm saying, what's 1/2 of -6? What's 1/2 of -6, Tatiana? -3x. So we did distributive property. The only thing we didn't use yet is this plus 2x and the equal sign. So we have now done distributive property. And remember, we did that by scanning the whole question and looking for it. You're trying to see, are there parentheses with a number right outside? Are there parentheses with a number right outside? That's what you're looking for. So we did distributive property. What's next? Go ahead, Natalie. What are they? Good. There you go. -3x and 2x are the like terms. Now Christian said, well, what about putting this with it as well? Well, you can't because it's not on the same side of the equation. Only things on the same side can be simplified. Opposite sides you can't do anything with yet. And remember, we are still simplifying. We are not solving yet. So what do we get when we do -3x and 2x? Angela? Negative x, negative 1x. So we get negative, I'll put the 1, why not? 6 minus 1x equals, and now we've got negative 5x minus 10. So we've done like terms. Are there any other like terms? Remember, like terms have to be on the same side of the equation. So that's it. So now we are ready to solve. We're ready for this. And so now we have our new goal of collecting all the variables on one side, and we do that by starting with the smaller coefficient. And so, which one is smaller? The negative 1x or the negative 5x? Which one is smaller, Von Travius? It is. You are right. And here's what we do with it. We do the same thing we've done with everything else. What's the magic word that tells us what to do when we're solving? I'll give you a hint. It begins with the letter I. What's the magic word? 3 light bulbs, 4 light bulbs, 5 light bulbs. Really? So many words with the letter I that you can't remember? Deja? Oh, not a word that we learned today, a word that we learned another day. Identity is something we're going to talk about, but identity is something different. You're going to kick yourself. You're going to literally kick yourself when you hear the word. Emily? Inverse. Do the inverse. So we are right here. Oops, excuse me. We are looking. Told you were going to kick yourself. We are looking right here. Von Travius said that's the smaller coefficient. Do the inverse of it. That says minus 5x. Now we have to do the inverse. What's the inverse of minus? Plus 5x. Plus 5x. But to do a transformation properly, what must we do? Kianis?
Do it to both sides.
Do it to both sides. Add 5x, add 5x. Elementary school line we use when we're solving. Remember, the first bunch of things we did was all simplifying. Now we're solving. And we're still working down, but now we have to add down. 6 and nothing is 6. Negative 1 and 5 with the x is 4x equals. These now cancel out, which is what we wanted. We wanted it to disappear. And then we have a negative 10. Don't forget the negative sign. The negative travels with the number that comes after it. Let's see who's been paying very close attention. How many steps do we have left? How many steps? Oh, we got 9, 10, 11, 12 people catching on. Oh, almost the entire class. Milan? How many?
2.
Are you sure? Yes, of course you're sure. There's 2 steps left. That was brilliant. 2 steps because it's a 2-step equation. Even though it's not ax plus b equals c, the ax is here, the b is there, the c is there. So now it's easy. Now it's smooth sailing. So let's do the smooth sailing together. What's the next step? Okay, let me put your hands down. Give me a thumbs up if you already did the next step. Okay, good. Tatiana, what's the next step?
Subtract 6.
You said that perfectly. Subtract 6 from both sides. Beware of this danger zone right here. That's going to cancel out, and we've got 4x equals danger zone. That's a negative 10 minus 6. What do we get as a result? Tristan? Very good. Negative 16. And now you can either use mental math or divide by both sides by 4, but this is pretty easy for my high-level students. 4 times what number is negative 16? What's the number? Ethan? Negative 4. So x equals negative 4. It's a lot of work, huh? That was one question. You're going to have like 20 of those for homework. Nah, not really. You're going to have 20 that look like that. You'll have a few that look like this. But more of them are going to look like this. And so now you're going to experience why I did that beast of a question first. I'm not going to tell you why, you're just going to feel it. So, our mantra is simplify, then solve. So let's start with simplify. And remember, when we talk about simplifying, we're talking about one side at a time, so we're really saying, what can be simplified over here? So can I have a volunteer? What's going to be simplified over there? 4x minus 10, what can we do? Crickets? We can do crickets. All my brave people left, or what can we do? Number 9 again. What can we do, Christian? What's that? Divide? By what? Divide by 4? Why should we do that? Okay, because you're just trying, right? Good. I appreciate you trying. Do you know why Christian's struggling to figure out what to do? Angela, tell him why he's struggling. What's that? Well, right, because we can't see the rest of it, but I'm asking you a simple question. What can be simplified right here? Simplified is not solving. Simplified means put that in the simplest form. Go ahead, Sean. Nothing. There's nothing to do. It wasn't supposed to be a trick question. It was just supposed to be an easy question. You were supposed to say, oh yeah, there's nothing to do. Is there distributive property in there? Are there any like terms? Nothing to do. Let's look at the other side. Let's see if we're catching on. What could be simplified here? Nothing. So now we are done simplifying. I know. Wow, it seems so much easier, right? So we're done with this. Now we're ready to solve. Where should we start? Where should we start? Jacob? Okay, but they're not really like terms yet because they're on opposite sides of the equation. So you got the right idea, you just can't say that they're like terms until they're on the same side. Shannon? And why should we start here?
Because it's smaller than 4x.
Yeah, it's smaller than 4x, and I think that's what Jacob was trying to say, that we're going to start with those, but we start with the smaller one. And so what do we do to it? What action do we need to take, Aaron? Okay. Can someone sum it up in 6 words? Isabella?
Add 3x to both sides.
Add 3x to both sides. Very good. Add 3x, add 3x. What's the word that starts with the letter I that told us to do that? Go ahead, Jacob. Redemption time.
Inverse.
Inverse. We do the inverse. This will now disappear, which is what we wanted. Here's what actually happens. It disappears and jumps to the other side. That's what happens. And now add down. Remember, we're still working down. 4x and 3x is 7x. Minus 10 equals 32. How many steps do we have left? How many steps do we have left, Melinda?
2.
2. It's just 2 simple little steps. What's the next one? Go ahead, Milan. You said it perfectly. See that? Even when the teacher puts you on the spot. Still, great success. Add 10 to both sides. 7x and nothing is 7x. That cancels out. Equals 42. Mental math. What is the final solution to part B? Sean?
X equals 6.
X equals 6. I love how you said x equals 6. Comments or questions on this? Which one seemed easier, A or B?
B.
Yeah, a lot easier, right? Because I made you do the hard one first, the other one seems so much easier. Because you didn't have to do all this. Now, you have to know how to do this, and you have to be able to deal with this, and you're going to get another hard question. But at this point, you should now be able to see that it's actually the same thing. Look right here. And look right here. It's basically the same thing. The only difference with the first question was it was hidden. We had to do all of this to find the hidden equation and then solve it. You guys are doing a good job. Let's see how you do on your own. I gave you a somewhere in between question. Checkpoint number 1. One question. You got 3 minutes. You got 1 minute team talk. See if you've got the same answer. See if you did anything different.
I got x equals 17. Which is
I got 3. What's 3 and 1?
yeah, my story has to be a fraction.
What did you get? 9.5.
All right. Team F, where are you? What'd you guys think? Okay, so we had a little bit of a difference of opinion. Okay, good. That's Team F. Team B. Team B, what did you guys think? You all had different answers? What was your answer, Sean? I thought I heard you say that you had the same answer. Go ahead, Isabella, what'd you have? Okay.
I'm still deciding.
Okay, so you weren't sure. Okay. Team A, what do you think, Mark?
I got 17.
Okay. What about your teammates?
They got different stuff.
So, Shannon, what did you get?
9.5.
What did you get?
3 and 1/5.
Okay. Natalie? And what about your team? They all agreed. $19.5 or 9.5? Yeah, Sean, I don't know why you said you didn't finish because I looked at your paper and that's exactly what you had.
Well, I got it right then, I think.
Yeah, but since you didn't think you got it right, I think we should mark it wrong. I'm just kidding. You can mark it right, but next time, don't stop, and next time, don't hesitate. Just finish. Just finish, whether it's right or wrong, finish. So, one thing I want to illustrate quickly with this is the nature of this year. Is you're going to be doing work that takes many steps. And there are so many different spots that you can mess it up. It takes one tiny little mess up and it ruins the whole thing. And it doesn't feel very good when it happens. So my goal for you is to be very aware of where these little mess ups happen. For example, one I pointed out in an earlier class was distributive property. Excuse me. The most common error with distributive property is not doing both arrows. That's why the arrows are so important. Distribute, 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 distribute. But what I have students say is, I got it, Mr. Gallant, I got distributive property, it's 5x minus 3. All right, I'm going to keep going. Minus 9x equals negative 2x plus 17. And now they're going to do a whole bunch of other stuff, right? There's 4 more steps. And they've already messed up. And they don't even know it. So that's first common error, doing distributive property wrong. So you got to do it correctly. You have to do both arrows. 5 times x and 5 times negative 3. So what do I get for this side of the equation? Aaron? Very good. Minus 9x equals, what will I get when I do that distributive property? Someone tell me the whole thing. Go ahead, Tristan. Outstanding. Negative 2x minus 34. So we're done with distributive property. What's next? It should be a list in your head. Distributive property. What's next, Kianis?
Combine like terms.
Good. What are they?
5x and negative 9.
Yeah, you should be looking right here and looking right there and saying, oh, there's like terms. 5x and negative 9x is? Ethan? No, we're having some trouble with our integer issues. Go ahead, Jacob.
Negative 4x.
It's negative 4x. Positive 5 and negative 9 is negative 4. Minus 15 equals negative 2x minus 34. Let's see who's really paying attention. How many steps do we have left? Jacob?
4.
It's a good guess. Milan?
3.
Yeah, there's 3. Which side has the smaller coefficient? Von Travis?
Negative 4x.
Yeah. So now you should be looking right here. And you do the inverse. Add 4x to both sides. This disappears. Negative 15. That's a danger zone right there. That's a negative 15. It must come down with the 1, 5. Equals 2x minus 34. How many steps do we have left now? How many steps do we have left? Milan? 2. It's a 2-step equation. Add 34 to both sides, divide by 2, you're done. So there was all these different places where you can make a simple mistake and get the whole thing wrong. You've got to be aware of that. Okay? Comments, questions? So, we got the easy stuff out of the way. Let's do the hard stuff. Example number 3, some special cases. Now, you won't know something is a special case until you actually do it. So you actually have to do the question, but then at some point, your spidey sense should start to tingle. We're following the same mantra. Simplify, then solve. Simplify, then solve. What can be simplified? You should be getting used to it now. You've seen like 5, 6 questions. What can be simplified? Christian knows I'm going to call on him. Go ahead, Christian. What can be simplified? Beautiful. Distributive property. You said that perfectly. Distribute. 2 times 4y, 8y. 2 times 5 is 10. It's 8y plus 10. Anyone notice anything? 1, 2, 3, 4, 5 people's hands went up right away. A whole bunch of other people's hands went up right away. Melinda, what did you notice?
They're the same expression.
Oh, I love the way you said that. It's the same expression on both sides. 8y plus 10, 8y plus 10. What is this called? What is this called, Ethan? Say it again. Right, they're identical. And the word that was in the notes was, it's called a what, Danielle? It's called an identity. It's an identity. You're right. I like the way you said that, Ethan, because they're identical. And what that means is no matter what number we put in, it will always work. If I put a 1 here and I put a 1 here, that's 8 plus 10 and 8 plus 10. It's going to work. If I put a 100 right here, that's going to be 800 plus 10 and 800 plus 10. It's always going to work. And so we write all real numbers. All real numbers will work. All real numbers will work. But what about, I'm sorry, are there any comments or questions about this? Good. What about this? W minus 1 equals W plus 7. Well, I don't know what it is, so let's just go ahead and proceed. What can be simplified? What can we simplify? Sean?
Nothing.
Nothing. So that means we're ready to solve. Which side should we start with? Which term should we start with? Go ahead, Deja. Which one? -1. Okay, so what should we do with it? Say the whole phrase. 5 words. Good. Add 1 to both sides. So let's go ahead and add 1 to both sides. Notice that I'm putting the 1 underneath the 7. That's on purpose. W and nothing is W. I'm sorry. W and nothing is W. The -1 and the +1 cancel out. Equals W and nothing is W plus 8. What's next? Sean? Okay, that's fair.
Subtract 8 on both sides.
Subtract 8 on both sides. Subtract 8. Subtract 8. That cancels out. And now we get W minus 8 equals W. What would you like to do next? Keons?
We can't do anything next.
Oh,
Why not?
Because if we keep doing that, we're just gonna keep getting.
Right, but we didn't do anything with the W's yet. I'm not sure why we haven't done anything with the W's. Sean?
you add both W's?
How do I add them? They're not on the same side, so I can't do that.
Okay, never mind.
Well, you had the right idea, Tatiana. What's that? Are you sure? Why can't we subtract W from both sides? Why can't I do that? That'll cancel out. Well, then that'll cancel out. We'll get -8. Oh yeah, that doesn't work. So Tatiana, what is this called? Yeah, this is called no solution. And if you think about it, it actually makes perfect sense. And you could start way back at the top. Remember that when you're solving an equation, you're looking for a number that makes it true. So let's pick a number. Put a 2 right here, which means you have to put the 2 there. 2 minus 1 is 1. 2 plus 7 is 9. Is that equal? No, that doesn't work. So we know that that's not the solution. So we could try again. We could keep trying, but no matter what number we put in there, it will never work. Because there's nothing that we could take that would subtract 1 and then add 7 and have it be equal to each other. That would never make sense. I could not take 2 classes that were the exact same size, subtract 1 from one of them, and add 7 students to the other and have them be equal to each other. That would never work. It just logically doesn't make sense. So this is called no solution. So you have 2 special cases that you must be aware of. All real numbers, no solution. If both sides are exactly the same, that's called all real numbers. If both sides are different and it won't work, that's called no solution. You have to be aware of both of these and what the difference is. Same, all real numbers. Different, no solution. Let's see how you do on your own. Checkpoint number 2. Solve that. You got 2 minutes. Got 1 minute team talk to see how you all did.
Did you get?
Well, it seems like the conversation for the most part has stopped, so that's okay. You guys are doing a great job. So let's see what we got. What'd you get? Oh, we got lots of confidence. We'll start with Danielle, and then we'll go to Jacob, and then Mark, and then Aaron. Okay?
All the numbers.
4 people seem to agree that it is all real numbers. How many steps did it take you to realize? Be honest. How many steps did it take you to realize? Sean? 2. Jacob? 2. Von Traeger? 2 steps?
2 steps.
Yeah, it took me about 2 steps to realize. Could take 3, could take 4. Some people could actually mentally see it right away. Just depends on how quickly your brain catches on. Any comments or questions on this? You guys are doing a great job, and I know it's tough to sit through something so long. We've got a little more to go. It's the real world application, but I want you to know that I'm very impressed with you guys. Keep up the good work. So this is the last example of the day, and really it's the most important. I don't think I've done a very good job of building up to this because over the last 2 lessons I've had to eliminate this part of the day because of time. So it's going to be tough. You do not have to copy this question. You need to write example 3, and then you need to read this to yourself. So go ahead and read to yourself. So, the best way for me to go about this is to start modeling. And it's going to take you some time. 1 example on 1 day is not enough. But this is where we start. So, this is a complex question. And algebra is actually the most efficient way to figure it out. There are some questions that I'm going to show you that you could just figure out through logic or just thinking about it. But And honestly, algebra is the most efficient way to figure this out. There's a lot of information to weed through, and I'm going to start teaching you some of my words that we're going to use to try and make it real and try and make it digestible. In other words, how to know what to look for. So here's something to look for. There are 2 characters in the story. If there are 2 characters in the story, that is different than if there's 1 character. 2 characters might mean 2 different expressions. 1 character might mean 1 expression. So what we're going to start with is writing down the names of the characters to start organizing our information. We've got Brett. He's going to be here. And we've got Chris. He's going to be right here. And we're going to look for some basic pieces of information. And again, this is a starting point. We're going to look for what's called a flat fee or a flat number. It's for both of them. A flat fee or a flat number is a number that doesn't change. It's just an amount of money or a number that doesn't ever change. Okay? Then we're going to look for what's called a rate. A rate is a number that depends on another piece of information. For example, my principal says that I have to have a minimum of 3 grades per week in my grade book. 3 grades per week. So the 3 depends on how many weeks there are. How many weeks of school has there been? 1. So there should be at least 3 grades for the 1 week. But what if there's 8 weeks? Now all of a sudden it's different. So the number changes depending on some other number. That's called a rate. Okay? The last piece is what is missing. What is missing? So let's start with Brett and start with the flat number or the flat fee. You can also think of it as a starting point. So what do you think the flat number or flat fee is for Brett? Mark?
5.
Okay, because he decides to save $5 of his allowance. But what comes after the word after the $5? Read the rest.
Of his allowance each week.
Stop right there. Each week. That is a clue. Each week tells you that this is what kind of number? Natalie? That's a rate. When the number is followed by something like each or per, that's a clue that that's a rate. So $5 is actually Brett's rate. Now let's take it a step further. Brett is saving $5. What could we put in front of the 5 to make it even more specific? What does saving mean? Ethan? That's right. He's adding $5. Since Mark pointed out the 5 and that's the rate, let's look for Chris's rate. What's Chris's rate? Milan? Chris's rate is 10. Because look, it says 10 each week. So let's put a 10 right here, but let's be more specific. What is Chris doing with his money, Isabella? And what do we put in front of the 10 for that? Yeah, he's losing $10 a week. Starting to see what's happening here? Now let's go back to the idea of a flat amount of money. A number that's not going to change without something happening. What is Brett's flat number or his starting point? Danielle? Yeah. A flat number is like a starting point right here, 60. So what is Chris's starting point or flat number? Shannon? 135. So we've got the flat numbers, we've got the rates. What's missing? What's the piece of information that's missing? Natalie? The weeks. We don't know the weeks. It's W. So now watch how easy this is to put together. The rate and the missing not always, but usually go together. So when we put this with this, and this with this, what will I write for that? The 5, the positive 5 and the W, remember it's a rate, it's per week. When you do something per week, what operation is happening? Angela? Good, so how do I write that? Plus 5W. What about Chris's? What's his going to be? Oh, come on, guys. I know it's the end of class, but we can, you're now seeing a model. You can do it yourself. Sean? Minus 10W. But what's Brett's starting point? Right? This is something that's going to happen, but now he's got this starting point, 60 plus 5W. And Chris's starting point is 135 minus 10W. And then it says, after how many weeks will Brett and Chris have the same amount? What should I do now to represent the same? Kianis?
Put an equal sign between them.
Put an equal sign right between them. That's what you're being asked. When will this be equal to this? Once we solve that, that will tell us how many weeks. Okay? So, in your homework, you're going to have questions like this, and you're going to have to solve it and find the answer. In the interest of time, what I'm going to do is I'm going to hit the pause button on this question. I want to focus on how to organize information, and so I'm going to give you a checkpoint. But don't worry if you don't know what you're doing. You're going to try. Okay? I don't expect you to have mastered it yet. So it's a different question, but I want you to write checkpoint 3. I want you to read it, and I want you to try and organize the information and write expressions for the two characters in the story. So what you see we did here, I should see something similar for here. Okay? So, go ahead. You got 2 minutes to read and organize the information. me a thumbs up if you have an equation set up. Okay? So team talk it and see if you got the same one. You got 1 minute to see if you guys have the same one. Try to come to an agreement on the equation you set up. Same one? That's pretty good. So, a lot of you guys seem to agree. Is this what we had?
Yes.
Pretty impressive. I'm very impressed. I have the answer. It comes out to about 2.5 years. It actually comes out to exactly 2.48 years, but it's about 2.5 years. You didn't have to do that. I just wanted you to set up the equation. Very good. I'm very proud of you guys. That's awesome that you figured that out so quickly after only one example. Okay? Normally I would stop and take questions, but we are way behind. So, draw a line across your paper one final time today. Your homework is in the student book, which again you do not have, so I gave you a copy of the page. It's on page 31. You're doing 1 through 14. Make sure you write this down. On page 32, which is the back, you're only doing numbers 1 through 4. There's 20 questions. Make sure you write down that there's 20 questions. You can't do the reading assignments, and you are going to have a quiz. Well, you're going to have a quiz tomorrow. And it's going to be 1-1 through 1-4, so it won't include today. It only includes up to the last lesson. Okay? So, if you've done your homework and you've done your job, you should be okay on the quiz. As soon as you are ready, you may pack up all of your things